Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 1, Part 2, and in this lab I created a 2-to-1 multiplexer, just a very simple entity and architecture for VHDL. But I didn't mention in the previous video, and I didn't show actually either, for this course, this digital logic course, I'm going to be using VHDL and Verilog. I know in FPGAacademy.com they are separated out. You can take the VHDL path, or you can take the Verilog path. I'm going to be taking them both simultaneously because I think that's a really good way to learn the hardware description languages. Okay, but getting into the code, we can see that in our entity we have a few inputs and a single output. And as a multiplexer acts, it's basically an if-else statement with that selector switch. So if select in this case is high, then B will be high, and if select is low, then A will be high. And it's basically an if-else statement in digital logic. But we can see in our architecture, we're actually using a data flow model. And I think the dead giveaway for that normally is the fact that we're using those logic gate symbol names, not and, or, XOR, etc. And so that's why it's a data flow. But we can see from that, we've knotted select. If not select is high, that would mean if it is 0 and A is high, then Y will be A. Or, and the OR is with the logic of OR. Basically, it'll accept one. The output will be high if one or the other is high. And on the right, we can see that select is high and B is high. So if they are both 1, then the output will be B. And that's it. And we see a similar thing in the Verilog code. We declare an input wire A, B with a select, and then we have our output wire Y. We assign Y to if select is equal to 1, not B0. And then this is a ternary operator actually. So if this is true, we select A. If it is false, then we select B. And this would kind of reverse it if we were to say put a 1 here in this part, because this is 1 bit wide and the value would be 0. But if we were to flip this to be 1 and we had the switch high, then the output would go to A and then B would go to the output if the switch were low. All right, here we go. We're going to show the 2-to-1 multiplexer, and we see on the side here we have our 2 switches. This is switch 0, switch 1, and switch 2. And so we have A for our first switch. I'm actually going to move this a little bit so it'll be easier to see. We have A, B, and select there. Our output here, Y, is just LED 0. And if we flip A high, we'll see it go high as we have select switch to be low. And if we flip select to be high, then we'll see that A does not go high with it, but B will. And the reverse, if we were to flip B high, we see nothing. So we know that only A is going to be selected for this part of the mux. All right, that's it. Thank you.